Object-oriented concepts. The object-oriented approach helps us to produce complex software that is more reliable and cost-effective. Object-oriented is comprised of three principles: encapsulation, polymorphism, and inheritance. So let's take a look at them closely. Encapsulation, as you recall, objects know stuff and can do stuff, combining data and operations. This packaging of data with a set of operations that can be performed on the data is called encapsulation. Encapsulation provides a convenient way to compose complex problems that corresponds to our intuitive view of how the world works. From a design standpoint, encapsulation separates the concerns of what versus how. The implementation of an object is independent of its use. The implementation can change, but as long as the interface is preserved, the object will not break. Encapsulation allows us to isolate major design decisions, specifically ones subject to change. So polymorphism is another concept. Literally, polymorphism means many forms. When used in object-oriented literature, this refers to the fact that what an object does in response to a message, a method call, depends on the type or class of the object. Polymorphism gives object-oriented systems the flexibility for each object to perform an action just the way that it should be performed for that object. And finally, inheritance. The idea behind inheritance is that a new class can be defined to borrow behavior from another class. The new class, the one doing the borrowing, is called a subclass, and the other, the one being borrowed from, is called a superclass. This is an idea our examples have not included. Just note that both inheritance and polymorphism are not explicitly covered in this class, yet they are very important, and then your future object-oriented programming classes will probably extensively cover.